All right. So I've not done one of these with the microphone things on their ear. I've done it once, but it's been a couple years. Can everyone hear me okay with the mic on? Okay, cool. Well, today we're going to be giving hopefully a pretty good mix of depth and breadth for Foundry. And I just want to start off just out of curiosity. Has anyone here built any applications with Foundry yet? Okay, and then what about with Hard Hat or Ganache or any of these other, okay, cool. So it's basically, Foundry is in the same category as Hard Hat. And if you're like me and you started off writing smart contracts anytime more than a year ago, or even if you started in the last few months, you often will see tutorials still kind of using Hard Hat or Brownie or some of the other tools and frameworks that were out there before. But Foundry's a little newer, and in my opinion, it's better for certain things. I like it a lot. When possible, I use it. So hopefully by the end of this workshop, you kind of have an idea of how Foundry works. So it's going to be composed of a quick overview of Foundry, and then we're going to actually do a workshop. And I have a linked code base that you can actually follow along, copy and paste, and have kind of your own code base to work with. So my name is Nader. I'm the director of DevRel at Aave companies in Lens. And I've been a software developer for about 11 years. I've been working in blockchain for about 2 years. Before that, I was at AWS for over 3 years. And then before that, I was doing all sorts of stuff in more of the startup world. So Foundry is a portable, fast, and modular toolkit for Ethereum application development. That's kind of their overview of it. But more specifically, we're going to talk about why people would use Foundry over something else. And one of the main value propositions of Foundry is that everything is Solidity. That's kind of the main difference, I think, if you wanted to kind of really boil it down and distill the difference between Foundry versus Hard Hat or some of the other tools that are out there. So when I first started building with Hard Hat, it was really simple to to kind of learn how to write Solidity and do my smart contracts. But when I wanted to write tests and things like that, I had to then understand the JavaScript libraries that were interacting with my smart contracts and deal with things like big numbers and conversions of different types and things like that I didn't really want to deal with. So with Solidity, if you're writing everything in Solidity, you obviously just don't have to deal with that. So that's a big value proposition, is that you're just writing everything in Solidity. The other value prop is that it's very fast. It's written in Rust and therefore is much faster than maybe JavaScript. It has a really nice developer experience. It has things that you just don't have with other tools. One of those things is fuzzing, and it's a way to do more, I would say, automated types of tests that will come up with use cases and I would say cases that just you might not catch in a traditional JavaScript test. And we're going to demo that as well. They also have a built-in library for RPC calls. So with Foundry, you're actually dealing with 3 separate CLI tools that we're going to go over in just a moment. And you can actually use these tools separate from a Foundry quote-unquote project. So you can actually just interact with random RPC endpoints using some of these tools as well. So it's not only for smart contract development, but it's also for interacting with smart contracts that are deployed on a EVM-compatible network. And those 3 tools are Anvil, Forge, and Cast. So Anvil is the way to run a local Ethereum node. So with Hard Hat, you would run npx Hard Hat node, and it spins up that local node. With Foundry, you have Anvil. You also have Cast, which is a CLI tool that interacts with different deployed EVM smart contracts. So with this, you can do stuff like send transactions, you can read data from a deployed contract, et cetera. Some stuff that you might have done locally using JavaScript or some other I would say library like Ethers.js and things like that. And then finally with Forge, this is kind of the main thing that you're going to be using when you're developing with Foundry. And with Forge, you can run tests, you can run builds, you can deploy your contracts, and you can run scripts and all sorts of stuff. So with that being said, what we're going to be going over today is the Foundry workshop, and I'm going to be going to a GitHub repo that you can actually follow along with. And then the other 2 resources I would recommend if you want to learn more about Foundry are the Foundry book and the Foundry cheat sheet. The Foundry cheat sheet is like a condensed version of maybe this workshop with a lot of like links and references to the most common things that you're going to do. It's kind of like the Pareto principle, like what's the 80% of things that you might do with a particular tool. It's all outlined in that cheat sheet, and I think that's a great place to get started. So with that being said, we're going to jump now to the actual workshop. And this is a step-by-step guide for testing out all of the main tools and APIs that Foundry offers. And we're going to start really basic, and then we're going to get more advanced. And if you want to follow along with this in the future or now, it's at github.com/Dabit3. And then one of the top repos should be the Foundry workshop. If you go to my repos here, it should be like the 5th repo there. Okay, cool. So with that being said, what we're going to do is kind of jump down here to the getting started part. And I'm going to go ahead in my terminal, and I'm just going to open up an empty directory. And with any Solidity environment, or with really any development environment that's not anything you've worked with before, you might want to configure your VS Code to work with that. So with VS Code, there's a Solidity plugin that you might already have. And then within that Solidity plugin, you have a configuration or a settings panel that kind of lets you set up things like dependency paths and so on and so forth. So this isn't anything that you strictly have to do, but it might be a good thing to do to go ahead and configure the SRC directory for your package default dependencies contracts directory. And this is just going to tell the IDE where to look for your smart contracts. And you're saying look in the SRC directory because that's what Foundry does. And then the package default dependencies directory is going to be lib. If you've used JavaScript, you might be familiar with node modules. Well, in Foundry, it's lib. That's where the things are stored. So if you've been writing with hard hat, this might be configured to node modules. So just something to keep in mind if you see any like syntax highlighting errors in your IDE when you're building right now. So that's outlined here. So if I go to like VS Code and I go to user settings, I'll look for Solidity. I'm going to zoom in. You'll see that you have like all these settings, and if you go down to the package default dependencies contracts directory, and you'll just see the exact thing that I kind of outlined there. So just something to keep in mind if you are running into any issues. So to install Foundry, you basically just need to run this curl command, and it will install it for you. And then you have this tool called Foundry Up, and Foundry Up will update Foundry to the most recent version anytime that you've kind of gone a while without using it. And then at that point, you will have 3 CLI tools available to you. One will be Forge. So if I run forge-h, you'll see that we have all of these different options. If I run cast.h, you'll see that I have these options. And if you run anvil.h, you'll see that we have these options. So you now have Forge, Anvil, and Cast. So Foundry actually is not Foundry. It's actually 3 separate CLI tools. And those are the 3 tools that kind of make up Foundry, as opposed to Hard Hat, where everything is just like npx Hard Hat. So what we want to do is initialize a new project. So with Hard Hat, you might run npx Hard Hat init, or whatever that command is. With Foundry, it's it's Forge init. So Forge is like what we're going to be doing to get started building that. So what I'm going to do is run Forge init, and this is going to go ahead and create a new folder in my directory here. And you'll see that we have these folders created for us. The main 3 things that we're going to be working within are going to be SRC. This holds the actual smart contracts that we're going to be building. And it starts you off with like a counter contract. We also have tests, and we also have scripts. I think the smart contracts are self-explanatory. The tests are self-explanatory. Scripts are where we run things like deployment scripts and things like that. So if we want to actually deploy this contract, we would go to this script, and we would run a script. And we're going to go over that as well. And then for any dependencies, so for instance, later on, we're going to install the dependency for us to have a reference to an ERC 721 contract from OpenZeppelin. When you install like a node modules npm install, it goes into your node modules folder. We're going to be running Forge, I believe, install or something like that, and it's going to go into this lib directory. And right now we have the Forge standard library that comes packaged with a new Forge project, a new Foundry project, and this gives you tools for testing and things like that. When we install OpenZeppelin, you'll now see that we'll have two dependencies. We'll have the standard library, and we'll have the OpenZeppelin contracts. And you've probably used OpenZeppelin contracts in your workflow already. So with that being said, the counter contract is great, but we're going to actually replace that with something that will allow us to do a little bit more, but it's still really basic. It's kind of like a hello world contract. So I'm going to go ahead and copy the code that we have for this hello world, and we're going to paste it there, and I'm going to rename the contract to hello world. And here, that when we deploy the contract, you'll see that we have a single argument that comes into the constructor that sets a greeting or a message. We then have a function that returns that message, and then we have a function that updates that message. And then every time we update the message, we increment the version number of the app. So really basic stuff, just a string being stored along with an integer for the version. And this will allow us to do a couple of things for testing that will make sense in just a moment. The next thing we do want to do is run our test or create a test for the smart contract. So what I'm going to do is copy the test that we have here, and we're going to rename the test that we have already set up to hello world.t.sol. And we're going to go ahead and do that here. I'm not sure what that message is giving me. No? We'll figure it out in just a moment. Anyway, but when we'll walk through the test. So you have this setup function that sets whatever you want to be used in all of the tests that you have going forward. So for here, we're setting up a variable called hello that is equal to a new instance of this hello world contract. And from then on, we can kind of reference that hello. So anytime we want to kind of reference that initial state of that contract, we can just say hello instead of having to initialize and deploy or quote unquote deploy a new instance of that. So here we're saying for the test, the first test, we want to call hello.greet, and we want to see that the initial state is set to the initial constructor argument of Foundry is fast. And then what we want to do now is kind of update that greeting, set a new message, and then we want to set or check that the version has been incremented to version 1. And then we want to also assert that the value of that greeting is set to hello world as opposed to Foundry is fast. And I have like a highlight here, so I'm not sure if this is going to fail because of something that I've done wrong, but what we're going to try, though, is to run this test by running Forge build. Okay. And then we're going to run Forge test. Okay, cool. So the test ran, the build ran. When we run Forge build, you'll also notice that we have this out directory, and this is where all of our ABIs are stored. So if you're building like a client-side application, you need your ABIs. This is where you'll find those. So here is the ABI for our Hello World contract, and this is kind of what you would use if you're going to obviously need your ABI for whatever reason. So that's pretty basic stuff. But we now have kind of everything set up to start looking at some of the cool features of Foundry beyond that. So what we're doing here in the tests so far is that we're kind of using this assertion library, and these assertions are available from this Forge standard library test.sol file, I guess you could say. But beyond just basic assertions, you can do other stuff as well. So you can kind of set or check to see truthiness. You can assert values based on not only strings but also integers as well. You can do greater than, less than, equal to, etc. And there's an actual link here to kind of show you all of those assertions. So like just understanding all the different things that are available for assertions gives you a lot of idea around how you can write your tests in Foundry. The next thing we want to look at is fuzzing. And the basic idea behind fuzzing would be if we wrote a function and that function took in an argument, what if instead the framework could automatically generate that argument for us? So every time we ran the test, it would kind of come up with something new that maybe would be unexpected and more likely to fail the test if there was any error. And that's kind of what fuzzing does. So we're going to update the test to add this new test. Or maybe we'll just be replacing this test too. And instead of using a hard-coded string like we did before, we're going to just say we need a string to be passed in as the argument, and we have no idea like what that string is going to be. And then we're going to run tests on that string. And in this way, we're able to kind of like randomly generate arguments that come in, and instead of having to hard code those. And then when you run this test multiple times, it will have different things that come through that might not have been caught had you kind of written your tests maybe with a hard coded value. So what we're doing is the same exact thing as we did before. We're checking the version, we're checking the initial state, we're updating the state, and then we're checking that as well. So if we run forge test, then we see that everything works as expected. So the next thing we want to look at is logging. And with logging, you can log information out, which is very helpful. You might have obviously used console.log in JavaScript. This is kind of the same idea. Every language typically has like a way to log stuff. And there are three main methods that you might consider working with: log, log string, or log name string. Log is the most generic version of logging. You can kind of just pass in anything there that you would like. And that's kind of what we're going to be using. And in order to emit a log, you actually have to pass in the verbose flag to your test. So what we're going to do is we're going to update our test. And what we're going to do is log out the value before we do the assertion. And then we're going to do the assertion there. And you're going to notice, like if I run tests like we did before, we don't see any logging at all. That's because you have to pass in that verbose flag. So if I pass in dash, I think it's dash VV, up to 4 different Vs, then you'll see the logs show up here. So if I pass in dash VV, you get more verbose logging. But most of the time, I think the 2 Vs is all you really need to kind of just see what's happening in your contract. So the next thing we want to do is take this contract, deploy it to a network, and then test it out on an actual live network. Now we could deploy this to like a test network, I guess, but we could also run it on a local node, and that's what we're going to be doing here. And to run a local node, you simply need to type in the word Anvil. So I'm going to go here, and maybe I'll split the screen like this, and I'm just going to run Anvil. And this will automatically spin up a local network, and just like Hard Hat Node, it will give us like 10 different accounts or private keys. And then we can use those maybe in our Ethereum wallet or something like that. And it's available on localhost 8545. So what we can now do is deploy our contract to this local network and then run scripts against it. So in order to deploy, we need to have a deployment script. And that's what we're going to do next. So I'm going to go to the scripts folder where we have the counter.s, and we just need to replace that with hello world, because that's what we're kind of working with now. And we're going to walk through what's going on here. So what we're going to do is import the hello world contract here, and then we're going to have this run function. This is going to deploy our contract. And what we're going to do is call this broadcast function, and then we're going to call the new instance of that contract. There's a couple of different ways to work with broadcast. I believe there's either you run broadcast and then everything that comes after that gets broadcast, or you can kind of have more granularity over broadcasting what. So you might do more, you might take more actions, do more things in this function, and then you might call broadcast once, or you might want every single new contract that you're working with to be broadcast. So the documentation is pretty clear about that, how that works. But for us, we're just going to be working with this basic contract. So what we can now do is deploy this contract to our local node. And this function really is all that you kind of need to see what's happening there. Now, what we want to do is reference a private key. And in order to do that, we're going to set an environment variable. So I'm just going to go snatch one of these private keys. It doesn't really matter which one. And then I'm going to say export, forgot what I called that here, just private key, I guess. And then set that to one of those private keys. And now if I echo, we should have that private key saved in our local session. And this is the command that we're going to be calling to deploy that. And here you see we're kind of referencing that private key, but we'll start with the beginning of what's happening there. We're going to say forge, and then we're going to say script. So we're going to say, okay, we want forge to run a script, and then we reference the script. So the script is script/helloworld.s.sol, and then we're kind of referencing the exact script that we have that we want to call there. So if I go here, you'll see we have this contract script, and that's the script that we're running. Now we need to specify which node we want to deploy this to, because we can either deploy this to a live network, which you would just paste in an Alchemy RPC or an Infura RPC endpoint, or you want to run to a local node, and that's kind of what we're doing here. So we're setting the fork URL as that local node running at localhost 8545. And you can simulate this without deploying it by running this script and leaving out the broadcast flag. So maybe we'll try that first. Let's see here. I don't know. Let me try the full deployment script and see if I'm missing something. Good call. Thank you. This needs to be .s for script. Yeah. Okay, cool. So we'll try that again without the broadcast. There we go. Thank you. Anyway, so this kind of simulates the deployment. So this way we're not actually deploying it. We're just kind of seeing how much the gas would cost and things like that. And now we're getting this message here that says simulation complete. If you want to broadcast these transactions, you need to add a broadcast flag. So that's all we need to do to broadcast this. And you should see that you see some feedback here that this has actually been deployed. And now the deployment is hopefully successful. And then logged out over here, we should see the contract address. And using this contract address, we can now make calls to that contract. So what we want to do is we have a couple of things we can do, right? We can read the contract, we can write to the contract. The first thing we might want to do is just read the current state of the contract. And the current state should just be version 0 and Foundry is fast. So to do that, we're going to use cast. So we've used Forge and we've used Anvil. Forge, creating a project, running scripts, things like that. Anvil, running the local node. Cast is for making RPC calls. So with cast, we can say cast call, and we can say cast send. Cast call for doing read operations, and cast send for write operations. So to do that, all we need to do, we don't need a private key or anything to read, right? All we really need is a contract address, and we need to know the function we want to call. So for the contract address, I'm just going to set that in a local environment variable as well. I'll set that equal to that. And now we should be able to run cast call referencing that contract address. And there we go. Our response is coming back hello from Foundry. And now we're going to make a state update. So we want to take that current state of hello from Foundry, make an update, and then read the next updated state of that. So to do that, we need to use cast send. And to send a transaction to your network, you have to pay some gas. Therefore, you need a private key or some way to pay for that by referencing an account. So that's what we're doing here. We're going to say cast send. We're going to call update greeting with whatever we want the new greeting to be. In our case, it's my new greeting. And then we're going to define like the path for the private key. So I'm going to go ahead and run that. So here we have cast send, contract address, and then the new greeting should be like my new greeting. And to test that out, we should be able to run that previous call, and then the greeting should be my new greeting. So we've successfully run the local network, we've deployed our contract, we've read from it, we've updated, and now we've read from it again. So that's kind of the main introductory to using the main three tools. But I think really what's powerful is being able to install other people's code, like how powerful NPM is and all the different libraries that are out there. And that's what we want to do here. We want to install the Open Zeppelin contracts, and we want to deploy a NFT ERC 721 contract. And we only have about 2 minutes left, so I'm going to try to make this kind of quick. But anyway, the workflow will be something like this. You install the package. You might want to reference the package location if you need to in your remappings to kind of let your IDE and the compiler know where to find those things. And then we just want to use the contract by importing it. So to install, we're going to run forge install, and then we're just going to reference the package. So again, this is kind of like npm install, but we're using forge. Oh yeah, okay. So in order to do this, I need to just run git add, git commit. Okay, cool. So you can't forge install unless there's no git history that hasn't been added yet. I guess to make sure you don't fuck anything up. So, so forge install. Well, what's going to happen after this? We should be able to go into our into our lib directory, and we'll now see that we have two dependencies. We have Open Zeppelin contracts, and now we can just reference ERC 721 contract from there or any other contracts that are there. So that looks like it was successful. What I'm going to do now is I'm going to go to remappings.txt, which doesn't exist yet. But remappings really kind of just tell the compiler and your IDE where to find certain directories or libraries or whatever. So if you run forge remappings, I think, it'll tell you all the remappings that you currently have set up. So by default, we already have forge standard library. We have DS test, which is the testing library, I guess, within forge standard library. And it looks like we have this Open Zeppelin contracts already kind of set up for us. So I'm not sure if we actually need to do that right now, but I'm going to go ahead and add that just in case to see the difference. Okay, got it. Okay, so now we have two remappings basically set. We can either reference the Open Zeppelin contracts using @OpenZeppelin or Open Zeppelin contracts. I must have made some update or something that didn't make a lot of sense. Okay, I think I see the difference now. Yeah. Okay. So basically, what we're doing is we're mapping the library instead of having to type out the entire directory. We can just say @OpenZeppelin. Anyway, so we're going to now test this out by creating an ERC 721 contract. So I'm going to copy this code, and we're going to go to our SRC library, and we're going to create a new contract called ERC721.SOL. And this is pretty basic stuff. We're just going to import the ERC721 contract, and we're going to have like this mint function that allows people to mint a new ERC721. And we're going to write a test for this. And I'm going to rush through like the beginning part of this, but then we want to look at one last feature before we wrap up. But the general idea is that we want to show how you can simulate other users within a test. So in this case, we have two defined users. We have Noah and we have Sophia. They're both initialized at kind of like an empty address, 0x1 and 0x2. By default, we're just going to like do some basic stuff. We're going to mint a token. But what we would like to do is like in our tests, we want to say, okay, Noah should be able to sell a token to Sophia. Sophia should be able to then resell it. But Sophia shouldn't be able to sell a token that she doesn't own. Noah shouldn't be able to spend the same token twice, stuff like that. So in order to kind of do that, you need to kind of simulate other users. So that's kind of what we're going to look at. So we're going to use this cheat code, was what they call them. They're kind of like helpers. And the one we're going to be using is prank. And prank essentially lets you simulate being another person. So for this transfer that we're going to test, we're going to be using that prank by saying, okay, we're going to first mint a token to Noah. Then we want to act like, okay, we are now Noah, and we want to take actions on Noah's behalf. So we're going to call VM.startPrank, and this will tell like the VM, the virtual machine, that we are now simulating Noah, and then we want to transfer the token from Noah to Sophia, and then you can think of all the things you might be able to do after that as well. And then we want to check that to make sure that the person that owns that is the person that should own that. Okay, so we're going to run this test, and we are now going to define which contract to test. Because if you just run Forge tests, we now have two tests. We don't want to test the Hello World contract. We've done that already. We only want to test the ERC721 contract. So with Forge, you can define which contracts you want to test. So in this case, we're saying we only want to test the ERC721 contract. Okay, so we tested the transfer, it passed, but the real test would be to see if we can change the owner of the token to someone else and make it actually fail. So we want to say, okay, the owner of this token should be Sophia, but we're going to actually set it to Noah. I'm sorry, let me change that. This needs to be Noah. There we go. And this should fail. Okay, cool. So that failed. That means that our test is working. We asserted ownership of a token. We transferred it. We made sure that the person that owned it after the transfer was the proper owner. Okay, so there's a little bit more, but I've already gone over on time, so I'm going to stop. But if you want to follow all of this from scratch, I think it's a great introduction to kind of all of the stuff that Foundry does and is good at. And again, beyond that, Foundry book, really great resource. And thank you. That's about it for me. I appreciate it.